Every program so far has used values written straight into the source code. That's rarely how real programs work. A program takes input from somewhere, processes it, and produces an output. This video is about the input and the output, how to get data into a program, and how to present the results. There are two common sources of input, and we'll cover both. The first is the user typing a value into the console. The second is a file, which is how you handle any dataset bigger than a few numbers. For the file side, we'll use a new library, Pandas, and for the output, we'll format our results with Python f-strings. The most direct form of input is the input function. It reads a line the user types at the console and hands it back to your program. So let's do that first. We'll say value equals input, enter a temperature in Celsius. The text in parentheses is the prompt, the message shown to the user before they type. When this line runs, the program pauses, waits for the user to type something and press enter, and then stores what they typed in the variable entered. One critical detail about the input always returns a string even when the user types a number. If we input a value 25, it's always going to store it as a string 25. So value would always be a string. And if we do any math on it, it's going to give you an error. So to use it as a number, we need to convert value from being a string into a float or a floating point value and then store it in a new variable, which is Celsius. Now we can do math on it, saying Fahrenheit. So we'll convert our Celsius value into Fahrenheit. So that's just Celsius times 9 by 5 plus 32. And then we can run the code. So it's prompting us to enter a temperature, and we'll say 25. And then now it's printing out the floating point value, 25 of Celsius. So they're both decimals. So the program prompted us, we entered a value, and it's converted and computed the result. That's the full cycle for the input from the user. So read with input, convert to the type that you need, then use it. Looking at the variable explorer, the data types are clear. Value is a string and the other two are floats. The line that we printed here is an F string. We briefly looked at it in the NumPy video, but we'll come back to exactly how it works once we have more to print. Now on to the next part. For a whole dataset, the input usually comes from a file, most commonly a CSV or a comma-separated value file, which is just a plain text table. So I have a file here called measurements, and then this is an example of a CSV. Here's our file. It's a super basic dataset, just a few rows with values separated by commas. The first line is the header, naming the column. So that's day, temperature, and humidity. To read a CSV in Python, we're going to use the Pandas library. NumPy from the last video is built for arrays of numbers. Pandas is built for tables, data organized into named columns. It's the standard library for loading and handling this kind of structured data. So let's start by importing NumPy as NP, and then we're also going to import Pandas as PD. By convention, Pandas is imported under the alias PD, exactly as NumPy is imported as NP. Sticking to the conventional alias keeps your code consistent with the documentations and with everyone else's. Now let's read the file. There. So read CSV takes the file name as a string and returns a data frame, which is Pandas term for a table. So it has rows and named columns. We've stored it in df, a common shorthand for data frame. We can also see it here where df is the name of the variable, and then our values have a header with column names day, temperature, and humidity. Notice the column of numbers on the left wasn't in our file. So if we look at measurements, we just start with day 1, 2, 3, 4. But our data frame starts from 0 and it has an additional column. That's the index, a label Pandas gives each row starting at 0, so you can refer to rows by position. Note the header parameter on read CSV. By default, Pandas treats the first row of a file as the column names, which is what we want here since our first row is day, temperature, and humidity. If your file has no header row and the data starts on the very first line, you'll tell Pandas that with header equals none. So you would say something like df equals to pd read CSV, and then you can say your file. And in this case, we don't, I don't have a file here, but then you would say header equals none. So if your file has no header and you leave this part out, Pandas won't give you an error. It'll just treat your first row of data as column names. So you end up with one fewer row than the file actually has. But we don't have it. I just wanted to show that this is something you need to say if you don't have a header. So moving on, before we actually start working with the data, let's check the structure. So 2 attributes are useful right away. These are the columns attribute and the shape attribute. So here, as soon as you print columns, it gives you the column names, and df.shape gives you the dimension as a tuple. Here, 7 rows and 3 columns in the same form as rows, comma, columns that we saw in NumPy. Both of these do not have parentheses, and since they're both attributes of the data frame, and so they're properties of the data frame and not methods that you can call. All Panda does is read and organize the data. To actually compute with it, we convert it into a NumPy array. The toNumPy method returns the table's values as a NumPy array, dropping the column names and the index. The result is an ND array, which is the NumPy data type. The type of data is ND array, and then the data that it's storing is a float64. So D type is a float64. Our file had whole numbers in some columns and decimals in others. And NumPy needs a single type for the whole array. So it promoted the integers to floats to fit the decimals without losing anything. That's the same type promotion behavior we saw with division in the NumPy video. Often you want one column rather than the whole table. We already have the whole thing as a NumPy array in data. So we can pull a column of it by index. So we can just say, if you just want the temperatures, you can say data and then it's the second column. So you will index it with 1. So we're just slicing and getting so this colon comma 1 is NumPy slicing on that 2D array, which is data. And the colon means every row and the second column or column index 1. You could also select the column straight from the data frame. So you could say df and then use this to get the temperature values, and then you can say toNumPy or something like that to use it if you wanted to stay just in Pandas. But since we're using NumPy and all our calculations happen in NumPy, it makes more sense to convert first and index the array directly. So we've been printing with f strings all along, but let's be precise about what they actually are and how to use them efficiently. An f string is a string with the letter f right before the opening quote. Inside it, any expression you put in curly braces gets evaluated and inserted into the text. These curly brace sections are called replacement fields. So let's calculate the average of our temperature. So we'll say temps mean, and we're calling the mean method on our NumPy array. And then we can print average. Average in these curly brackets is the replacement field. Python evaluates average and drops its value into the text. Anything that produces a value can go inside the braces. A variable, an arithmetic expression, a method call. But look at the number that it prints. It prints with a long trail of decimal places. Usually you want to control that, and f-strings let you with a format specifier. A colon inside the braces followed by formatting instructions. So what you would do is go inside the braces, give it a colon, and then .1f. The colon .1f after the value is the format specifier. Read it in two parts. The f at the end means the fixed point notation, so a plain decimal number, and the .1 before it is the precision, so one digit after the decimal point. Colon .1f says, show this as a decimal point with one digit after the point, which is why we now get a single clean decimal place instead of the long trail. That's the general form. So a value, a colon, and then how you want it displayed using the format specifier. You can set the number of decimal places, pad numbers to a fixed width to line them up in columns, and more. For everyday use, controlling the decimal places like we did here covers most of it. Two things to know about characters that already have a special meaning inside an F string. First, the curly braces. Braces mark a replacement field. So to print an actual brace character, you need to double it. So 2 braces gives you 1 brace in the print statement. The double braces in the print statement come out as a single brace on the console. And the single braced part still gets evaluated normally. Second is the quotes. The F string is wrapped in quotes. So if you need a quote inside the text, use the other kind. If the string is in double quotes, use a single quotes inside it, and vice versa. So let's look at an example. So the string is wrapped in single quotes here. So the double quotes inside print literally. The program now shows the full input-output cycle. Almost every program has the same shape. Take an input, process it, and produce an output. This video covered the two ends of that. For input, input reads a line from the user, always a string, so it has to be converted before use, and Pandas read CSV loads a file into a data frame, which to NumPy turns into a NumPy array for the math. For output, f-strings insert values into text through replacement fields and format specifiers, and control exactly how those values are shown. In the next video, we're going to talk about plotting, which is another way to present data.